All right, guys, so the first thing we're going to do here is look at how to integrate a really simple double integral. And so we're going to look at this example right here. The first thing I want you to understand is that the first integrand here, 0 to 1, is actually going to be represented by the dy. And then the second one right here, the 0 to 1, is going to be represented by the dx here. So as you can see, we're going to start inside and work our way out. So the very first thing we're going to do is we're going to integrate 4 minus 2y, but we're going to do that with respect to x. So since we're taking the antiderivative with respect to x, this actually is just a constant. So the first thing that you're going to do is you're going to write 0 to 1, and then you're going to integrate this. But again, since this is a constant, we're just integrating a constant with respect to x. So this is a number right now, so all we're going to do is just do it to the number x. Right? If I was integrating 3, that would be 3x. So this right now is a constant because, again, everything's with respect to x. And we're going to evaluate this from 0 to 1, and then we're going to go ahead and put our dy over here. All right? So then what I want to acknowledge here is that we're just replacing the 1 and the 0 with the x, right? Because we just took the derivative, the antiderivative with respect to x. So we're going to go ahead and write down 0 to 1 again. And so we're going to replace 1 here. So we got the 4 minus 2y to the first, and then minus 4 minus 2y, 0. So that's going to just go away. So we're basically just left with the integration from 0 to 1 of 4 minus 2y dy. And then the rest of this becomes super simple. We integrate 4 with respect to y, so that becomes 4y. We integrate negative 2y as y squared. And again, we're going to integrate that from 0 to 1. And using the fundamental calculus, we're going to plug 1 in, and we get 4 minus 1, all minus 0, and we get the answer of 3. Okay? So very, very basic stuff. So what we're going to do now is we're going to do the exact same problem. The only difference is that we're now going to start with respect of y. Okay, so we're going to do the same exact problem. The only difference, and by the way, I know this is doesn't make sense right now, but or the fact that this is 0 to 1 and 0 to 1, if this had been a 2 in this problem right here, then we would make this a 2 right here. So you actually would switch the integrals, but since they're both 0 to 1, it doesn't make a difference here. So we're going to integrate this from 0 to 1, and then we're going to see that now, since it's in terms of y, we're going to integrate 4 as 4y, and then we're going to integrate negative 2y as negative y squared, and we're going to evaluate that from 0 to 1, and then have our dx on the outside. Just like before, we're going to now plug anything into our y. So with this problem, we're going to go ahead and do the integration from 0 to 1. We're going to plug in 4 plug in 1, so 4 times 1 is 4, minus 1 squared is 1, again, all minus 0, and we get the answer, dx, and we get the answer of the integration of 0 to 1 of 3 dx. All right. And then once we do that, we're going to go ahead and continue with integration like basic calculus. We're going to go ahead and integrate x, 3 as 3x, and then we're going to evaluate that from 0 to 1, and we get that this answer is going to be 3 as well. So one of the things that's really cool about this is that you will see that these are going to be the same thing. So it doesn't really matter what order you actually integrate in, you are going to get the same answer as we do it. So what we're going to do now is we're going to look at example number 4, where we're going to do the exact same thing. So this is actually a little bit more difficult, but not too challenging. I do want you guys to see in this particular problem that the 1 and the 2, the integration from 1 to 2, is actually referring to the dx. And then the 1 to 3 is actually going to be integration of the dy. So the very first thing we're going to do here is we're going to, again, go ahead and just write down our double integral. We're going to do our 1 to 2 here. And now we're going to integrate 6xy squared, but with respect to y. So this is very similar to partial derivatives, where if I said let's take the partial derivative with respect to y, remember 6x is a constant. So that's exactly what this is here. So 6x is still going to be that constant. So we're going to go ahead and write down 6x, and then because we're evaluating with respect to y, we're going to then actually evaluate the value of y squared is y cubed over 3. And then we're going to plug that in to 1 to 3 dx. Okay, so that's the very first thing here. So again, very similar to partial derivatives that we talked about in unit number 3. So the first thing I'm going to do here is I'm going to take the 6 and the 3 and we'll pull that on the outside and get my 2. We're going to do a 1 and a 2 here. We're going to go ahead and put the x right here. Now remember, because we did this with respect to y, we're only plugging the 3 and the 1 into, and we'll go ahead and get rid of those so we don't get confused by that. We're going to go ahead and plug the 3 and the 1 into just the y, right? So we're going to have 3 cubed, which is 27, minus 1 cubed is 1, and then we still have our dx. And then we're going to do 2 times the integration from 1 to 2 of 26x dx. Okay? And then all we're going to do now, back to basic calculus, we're going to integrate 26x. It's just 26x squared over 2. And we're going to evaluate that from 1 to 2. And we're going to, guess what the awesome thing happens? Those 2's cancel out. So we're left with 26 times 4 minus 1, which is going to give us 26 times 3, which is going to give us the good old answer of 78. All right. So what good thing is here is that I would like for you guys to try part B and see that you are going to get the exact same answer that we got in part A. So I would suggest that you pause the video and then go ahead and try this problem. So as you guys can see, I went ahead and write down the problem for us. So I did 1 to 3. I looked at the fact that we're integrating now with respect to x. So the 6y, oh, there should be a square right there. 6y squared is the constant. And so we integrate x as x squared over 2. And then I canceled the 6 and the 2 out and made it a 3. Evaluate from 1 to 2 of our dy. Then once we did this, the only thing that's left is y squared, x squared. We're going to plug in the 2 where the x squared is. And so we get 2 squared is 4 minus 1. We get 3. So we simplified this down here in green. Then we said, well, let's pull the 3 out. So again, I love to pull as many constants out as I can. So I get the 9. And then I go ahead and do our good old basic calculus integration here to get the answer of 78. Okay, so just coming out of this video, what you should just make sure you understand is that you are always going to work your way inside out. So just really important, it really is just looking here first. And again, you're just assuming that the x is my variable. So I hope this is helpful. We'll get you in the next video when we continue on with more double integrals. So take care.